my freshmen. How are you? Miss Cancel here. I miss you a lot. I think you guys are doing a great job so far doing all this online work. I can't even imagine all the work that you've got from all the other teachers. It must be overwhelming, and I think you're doing great. So this quick video is to kind of go over the study guide so you're ready for tomorrow. I have the study guide here. The first part is defining terms. The first one is Earth. So we know what Earth is, right? It's a planet, the third planet from the sun in our solar system, and it's the only planet that we know that holds life, that supports life. The next one is crust. Crust would be one of the layers of the earth, is the uppermost layer of the earth, and it's very brittle. So very simple definitions. Plate tectonics. Let's see, plate tectonics is the theory that Earth exists in layers and that the top layer, the crust, moves due to convection currents under it. So there's convection currents on the layer underneath the crust, which is called a mantle. It moves in a very slowly manner, like that convection current, and that movement caused by the heat coming from the interior of the earth is what's causing these plates to move. And that's what the theory says, the theory of plate tectonics. Then we have the next one is oceanic floor or ocean floor. This is part of the crust of the earth, and it's a highly dense crust. It's kind of like a form of rock that lines in the bottom of the earth's largest bodies of water. So it's land, but it's underneath the water. And it's very, very dense compared to the other kind of crust, which is the continental rock crust. Very dense rock. Let's see. The next one is continental rock, which is the same as oceanic crust or rock, but in this case it's less dense. And we find it not underneath the water, but on the continent. Let's see the next one. The next one is the lithosphere. So the lithosphere is also a top layer of the earth, and it's half of it is the crust, and then half of it is a little bit of mantle. So it's crust and mantle. All right, let's see what the other one is. Then we have the asthenosphere. The asthenosphere is what lays underneath the lithosphere, and it's mainly mantle. Let's see what else. Then we have the last one, radiometric dating. So radiometric dating is used to determine the age of rocks and other minerals. You don't have to know the process. You just have to know that it's the method the scientists use to determine the age of rocks if they're studying them. All right, then we have the concepts. Concept number 1, explain the movement of tectonic plates. What processes are making these plates move? So the movement of tectonic plates, you just have to know that it's the movement of the top layer of the crust, the top layer of the earth, the crust, and it's moving due to the convection currents moving underneath the plates in the mantle. And this movement is caused by the heat from the interior of the earth. So the mantle is kind of like melted rock, and the consistency is not solid and it's not liquid. It's kind of like silly putty or clay kind of thing. So the convection movement is really slow, and that's why sometimes we get land formations and earthquakes and stuff like that. Number 2, what kinds of rocks are older and younger? Ocean floor rocks or continental rocks? So ocean floor rocks are the youngest because we have a lot of divergent boundaries underneath the ocean floor. So divergent boundaries is when two plates spread open and then new rock comes. So as that continues happening, every time the closer you are from one of those divergent boundaries under the seafloor, you will have very new rock. Because when that magma goes up, it meets with the water, it cools down, and it becomes rock, new rock. So the further you are from those places, the older the rock will be. And then the oldest rocks that we find are on the continental crusts because they're very far away from these divergent boundaries. Number 3, the blank you are from mid-ocean ridges. The blank the rocks you will find there. So again, the closer you are from mid-ocean ridges, the newer the rocks you will find there. Or it can also be the further away you are from mid-ocean ridges, the older the rocks you will find there. So it could be either way. Number 4, why aren't all rocks from continents the same age? So sometimes when we have plate boundaries, like mountains, we have two continental crusts that collide with each other, and because they have the same densities, they will both do this and make mountains. So those processes will bring some rocks from underneath the plates that are relatively younger. This is why sometimes we find younger rocks close to older rocks in these land formations, because that process of mountain ranges, it brings some of those younger rocks to the surface. And then the next one is define divergent, convergent, and transform boundaries. So divergent boundaries are the boundaries where the two plates are separating. Convergent boundaries is when the two plates are colliding with each other. And then transform boundaries are the times where two plates are sliding against each other. And then number 6, list and describe the layers of the earth. So the first layer of the earth is the crust. The crust is very brittle and it's very thin. Then underneath that is the mantle. The mantle is not solid or liquid. It's kind of like a malleable substance. And it bends with heat. Like a piece of caramel. Like if you have a piece of caramel and you bend it really quickly, it might break. But if you bend it slowly or if you heat it up a little bit, it'll be more malleable. Something like that. That's the mantle. The mantle is very, very, very thick. It's the thickest layer. Then after the mantle, underneath the mantle is the outer core, which is believed to be liquid and is believed to have a lot of heavy metals in it, like nickel and iron, because when the earth formed, everything was in a liquid state and all the heavy stuff sank to the middle of the earth. This is why the heavy elements are in the middle of the earth. So it's liquid because it's really, really, really hot, so it's in a liquid state. Actually, this outer core in the liquid state, because it has so much metals in it, it's what drives the magnetic field of the earth. That's very interesting. You don't have to know that, but that's interesting. And then in the interior of the earth, the innermost layer is the inner core, and it's also made out of metal, but it's not liquid. it's solid, and it's supposed to be liquid because it's really hot. So metals in that and those temperatures are supposed to be hot, are supposed to be liquid, but they're not because the Earth is creating this immense pressure, and it's making that inner core become solid, like obligated. It's obligated to be solid because of all the pressure, crushing pressure from around it. So that's your study guide. Tomorrow we have a quiz. It'll be during my office hours from 12 to 1. And your study guide is due tomorrow. You don't have to turn it in today because, you know, you can keep it so you can fix whatever you need to fix. You can submit it today, that's fine, but you don't have to. It's due tomorrow before the quiz. And it'll be a very easy quiz. It'll be on Socrative, but you may have your study guide with you while you're doing your quiz. So I expect everyone to do super well, all right? Take care. I'll see you soon.